Welcome back to the micromodule series, Understanding Bias in Epidemiological Studies. In this module, we will be focusing on another method for controlling confounding, which is multivariable regression analysis. The objectives of this module are to explain how multivariable regression analysis can help control for confounding and introduce the advantage and limitations of multivariable regression analysis. Multivariable regression models, such as logistic regression and Cox regression models, can include multiple variables in a single model and force the exposed and unexposed groups to be comparable in terms of the distribution of potential confounding variables through statistical techniques. The effect estimate, such as odds ratio produced by the model that includes the exposure only, is called crude effect estimate, while the one produced by the model that includes both the exposure and potential confounding variables is called adjusted effect estimate. A difference between the crude and adjusted effect estimates suggests the presence of confounding caused by the variables that are adjusted for, and the adjusted effect estimate is considered more reliable than the crude one. Let's look at a study that investigates whether smoking is a risk factor for hypertension. First, we estimate the crude odds ratio for smoking by designating hypertension as the outcome and including smoking alone in the logistic regression model. The crude odds ratio is 0.938 in this example. Next, we try to control for confounding caused by age by additionally including age in the regression model. The odds ratio for smoking after adjusting for age is 1.029. The difference between the crude odds ratio and the adjusted odds ratio suggests that there is confounding caused by age, and the confounding has biased the true effect of smoking towards the opposite direction. However, in this example, confounding does not constitute a big problem, as both crude and adjusted odds ratios suggest that the association between exposure and outcome is not statistically significant, leading to the same conclusion. The advantage of multivariable regression analysis is that it allows for adjustment of many factors at the same time, thus more efficient than previous methods such as matching and standardization. For this reason, multivariable regression analysis has been the most practical and powerful method for controlling confounding in observational studies, such as case control study and cohort study. However, it is important to note that the regression models are based on a number of statistical assumptions, such as linearity in linear regression models, proportional hazard assumption in Cox models, and so on, whereas the data being analyzed may not fulfill these assumptions, making it inappropriate to use these models. Furthermore, we cannot adjust for unmeasured variables in multivariable regression analysis. For example, in the above study of smoking and hypertension, dietary salt intake could be an important confounder according to prior knowledge. However, if it is not measured during the data collection stage, then this variable can by no means adjusted for in multiple regression analysis, and the potential confounding caused by it cannot be controlled. Okay, in this module, we discussed how multivariable regression analysis can help control for confounding and the advantage and limitations of this method. In the next module, we will talk about the use of random allocation for controlling confounding. Thank you for listening.